Hey everyone, today we're looking at Unit 4, Lesson 8, Graphing using the step pattern. So far when we've graphed a parabola, we've really looked at identifying those key points and then done a rough sketch. So what is our y-intercept, what is our vertex, and what are our zeros? We haven't really taken a look at the points in between all those key points. And so this idea of a step pattern we're going to introduce today is going to allow us to graph parabolas more accurately. It's also going to bring into play that a value that we've been talking about, but not really using very much. So we're going to look at a few examples today, and then we'll talk about how we can graph them. So our first quadratic we're going to look at is just what we consider or we call our base quadratic. It's going to be y equals x squared. So no coefficients added in, no x terms added in, just y equals x squared. So if we think about this in vertex form, because vertex form is the way that we would use our step pattern to graph, our vertex form is usually y equals a and then x minus h squared plus k. Remember, I said we're going to use this a value a bit more. So if we look at, we're just going to write used for step pattern. Okay, in this case, my a value is 1. So I just want to keep that in mind. A is 1, and that's the most basic step pattern we can have, is if a equals 1. But our vertex in this case, okay, I have nothing being added to my x, so there's no h. And I have nothing being added outside of my x squared, so my k is also 0. All right, so let's plot our vertex at 0, 0. But then let's fill out a table of values and see what some additional points would be. So we're going to do a table of values from -3 to +3. Okay, and then we're going to sub in our x values into our equation to figure out what's y going to be. So if I subbed in a -3 to x, okay, -3 squared equals 9. If I subbed in a -2, that would equal 4. Okay, and you could continue on with this. 1, 0. If you plugged in a 1, you're going to get 1 again, 4, and 9. Okay, so we are going to now plot those points. We're going to have 1, and then 2, and 4, and 3, and 9. And then we'll plot those points this way as well. And that's what our parabola is going to look like. I want us to take a second and take a look at, I'm going to erase this calculation I did here. I want us to take a look at what our first differences would be. And I want us to notice kind of what's going on with our first differences and the shape of our parabola. So if we were to look at our first differences, remember that's just comparing our y values. So as I go from 9 to 4, I'm going down by 5. And then as I go from 4 to 1, we go down by 3, and then down by 1. And then it starts to go the other way. So as I go from 0 to 1, we're going up by 1, then up by 3, then up by 5. Okay, so this first difference actually shows us something that's going on in our parabola. If we look at our vertex, so remember we identified what our vertex was, and our vertex is right here. Right, that's my vertex. So if we looked at what the points are doing from my vertex, we kind of treat this like slope. So if we were going to go over 1, our next point we have to go up 1 to get to it. And then from that point, if we were to go over 1 again, we have to go up 1, 2, 3 to get to that point. From that point we go over 1, and this time we go up 5. So 1, 3, 5 we can see is also in our step pattern, 1, 3, 5. Okay, if I go on the other side of my parabola and I work to see what's going on to get to my vertex, same idea here. Okay, I'm going from here, I'm going down 5 and over 1. And from this point, I'm going down 3 and over 1. and then finally I go down 1 and over 1 to get to my vertex. So on one side of my vertex, it's working its way down, right? Because it's working in one direction, and then that vertex is the turning point where the parabola starts going the other direction. So this is what we're going to be working with today. This is what we call our step pattern. Okay, so our step pattern comes from our first differences. So our step pattern here is 1, 3, and 5. Okay, let's try another one and see if we can start identifying what would our step pattern be. So if we had y equals negative x squared, again, our vertex is going to be at 0, 0. We see that we have an a value of negative 1. So this time our parabola should point down. But let's fill out our table of values and see what happens here. So I'm going to go from the same x value. So we'll go from negative 3 to positive 3. Well, this time when we plug in to our equation, we have y equals a negative, and I'm going to have a negative 3 squared. So a negative 3 squared is going to be 9, but then I have to put the negative on after that. So 9 is going to be negative. And then we'll have a negative 4, a negative 1, 0, and it'll go back to those negative 1, negative 4, negative 9. So if we plot those, here's our vertex. Okay. Our step pattern, let's see if we can identify that using our first differences. Okay, so as I go from negative 9 to negative 4, I'm going up by 5, and I go up by 3, and up by 1. Then after our vertex, right, because this is our vertex here, it's going to go start working in the opposite direction. So now we go down by 1, down by 3, and down by 5. So we could plot our points there, or from our vertex, we can just go, we're going to go up in one direction, and we're going to go down in the other direction. So at negative 3, we're going to be at negative 9. And then our step pattern says from there, we're going to go up 5, 1, 2, 3, 4, 5. And over 1, we plot that point, which is going to be at negative 2, negative 4. Then we go up 3, over 1, and we plot another point, and then finally up 1, over 1 to our vertex. Okay, and then on the other side of our vertex, it looks like we're going down. So we go over 1, down 1, over 1, down 3, over 1, down 5. So that follows our step pattern, which again, we could have just done with our points. Okay, and that gives us our shape of our parabola. We can see that it's opening down. So again, our step pattern in this case was 1, 3, 5. Okay, we're going to start talking about in the next examples, how can we find our step pattern using that a value? So we don't always have to put it into our table of values and plot it that way to find our step pattern. So this time, we're going to look at our a value and see if we can graph just from that. Okay, so our next example here, we're going to have y equals negative x minus 2 squared plus 3. Okay, so we can identify a couple things here. Our vertex is at 2, 3. So why don't we graph that? We're at 1, 2, 1, 2, 3. Our a value is negative 1. So again, it's going to point down. Okay, I'm going to use my a value to help me graph this. I'm not going to go right to my table of values yet. Okay, so if a is negative 1, we're going to take that a value and we are going to apply that to our base step pattern. So our step pattern is usually 1, 3, and 5. We're going to take whatever that a value is and multiply by that A value to our step pattern. So multiply by your step pattern. So I'm going to do 1 times -1. I'm going to do 3 times -1. And I'm going to do 5 times -1. Okay, so that tells me my new step pattern is going to be -1, -3, -5. So using our step pattern, we started our vertex. We're going to go over 1 and down 1 because our step pattern is a -1. From that point, we're going to go over 1, down 3, over 1, down 5. Okay, so our step pattern tells us that we're going to go over 1 and then up or down by the step pattern. That's how we use our step pattern. So we always go over 1 and then up or down by whatever the step pattern is. So we have to do that on both sides of our vertex. So on this side, we're going to go over 1, down 1, over 1, down 3, and over 1, down 5. Okay, we can connect those dots to draw our parabola. So you can see our vertex is at 2, 3. Okay, and our step pattern shows that we're going down 1, down 3, down 5. We can see that on the other side, down 1, down 3, down 5. Okay, so if we wanted to verify this using our table of values, we can again look at what's going on either side of this parabola. I'm going to use some values other than -3 just based on how we graphed this. So our vertex was at 2. So I'm going to do 3 points on either side of that. So I'll go 1, 0, -1, and I'll go 3, 4, 5. Okay, so if I substituted those values in, if I substituted in a -1, I'm just going to sub it in up here. So -1 minus 2 squared plus 3. Well, a -1 minus 2 is a -3. -3 squared is 9. Okay, and 9 with a minus on it plus 3 is going to be a -6. Okay, if I did that with all of my points, these are the values you should get. And if we took a look at our first differences, we would see that we're going up 5, up 3, up 1, and then it switches at the vertex. It's going to start going down by 1, down by 3, down by 5. So again, we're able to see that that is just our step pattern in our first differences, but we don't need to use our table of values. We can just go right to our step pattern. Let's look at one more example. So if we had y equals x plus 2 squared plus 1. Okay, our a equals 1, so it's going to point up. And our vertex is going to be at a -2 and 1. So we'll again start by plotting our vertex. -2 and 1, that's our vertex. And we know it's going to point up. So let's graph this using our step pattern. So if a equals 1, then I would take my step pattern of 1, 3, 5 and multiply by 1, which hopefully we're going to see that doesn't really change anything. So our step pattern is still going to equal 1, 3, and 5. So from my vertex, I'm going over 1, up 1 this time. Over 1, up 3. Over 1, up 5. So up 1, up 3, up 5. And we go on the other side of our vertex and do the same thing. Up 3, over 1, up 5. Okay, and when you see my dotted lines, we're not actually graphing anything there, and you don't even need to show them. Those dotted lines are more just to show you how I'm applying the step pattern to plot our points, which when we need to plot a point, you'll see I actually put a point in there. So if we were to, again, put this into a table of values, I'm going to put my vertex here in the middle, and then I'll do 3 points on either direction. So I'll go -3, -4, -5, and I'll work in the other direction, so it'd be -1, 0, and 1. Okay, if we were to fill out our table of values, we can look at the graph we've already created here. At -5, my y value is 10. At -4, my y value is 5. Then it goes to 2. And then we're at our vertex. And then we're going to repeat those points on the other side of our vertex. Okay, so that's how we use our step pattern. And we get a more accurate parabola because we're not just plotting our vertex and our zeros or our y-intercept. We're plotting the points kind of in between all of that. One more point for the note for today. I just want to draw your attention to that a parabola could have no zeros, it could have 1 0, and it could have 2 zeros. So there's a little bit of a shortcut we can identify with our a and our k value that will let us know how many zeros we should have in the graph. So we'll take a look at all 3 situations here so you can see how we end up figuring out if there's no zeros or if there's 1 or 2 zeros. So let's first identify when there's no zeros. So if a and k have the same sign, there's going to be no zeros. And we're going to do a little sketch here to show you what I mean. Okay, so if, let's say that a is positive and k is positive. So they have the same sign on them. They're both a positive number. Well, if k is positive, then it's going to be somewhere above my x-axis, right? My vertex is going to be somewhere up here. Let's say my vertex would be somewhere up here. If a is positive, that means it's going to open up. So if it opens up and k is positive, then it's never going to cross the x-axis. Or the same is going to be true if both of them are negative. So if a is negative and k is negative, right? If we take a look at what that sketch is going to look like. Again, if k is negative, it's going to be somewhere below my x-axis. So it could be like somewhere down here. And then a tells us it's going to open down. So same idea, it's never going to actually cross the x-axis, so there's no zeros in that case. When will we get 1 0? We will get 1 0 if and only if k equals 0. So if a is positive, oops, I just drew a plus sign instead of writing out that whole word. So if a is positive and k equals 0, so a rough sketch of that would look something like this. So if k is 0, that's telling me that it's sitting right on the x-axis. We don't move up or down at all for our vertex. So if k is 0, let's say, over something and up nothing, and then a is positive, the vertex is going to, or the parabola is going to open up. So you can see we only have 1 0. It only hits the x-axis once. Or if a is negative and k is still 0, we could draw what that would look like. So if our vertex was over something and then k was 0 or y was 0, it's still sitting on the x-axis. This time it's opening down. So you're still only going to have 1 0. And then the last scenario, which is the one that we see the most often, is if we have 2 zeros. And this is going to happen if a and k are opposite signs. So if a is positive and k is negative, take a look at what that might be. So if I was to draw this, okay, my vertex is over something and down something, right? So we're down here. And then my a value tells us we're going to go up. So if we go up from here, we're going to see that we cross the x-axis 2 times. So we have 2 zeros. The other scenario might be that, well, what if a is negative and k is positive? So we're going to see the same kind of thing is going to happen here. If k is positive, that's we're going to go over something and up something, right? Because my k value is positive. But then my a value tells me it's going to point down because it's negative. So again, we're going to cross that x-axis 2 times. So we'll have 2 zeros. So that's how we can identify how many zeros we're actually going to have in a parabola. If they're the same sign, we're going to have no zeros. If they're opposite signs, we're going to have 2 zeros. And if k equals 0, then we'll just have 1 0 or one x-intercept. That's all for your note for today.